So let's test the convergence of these series. And a good rule of thumb, if you see a factorial in these, would be typically the ratio test would be the way to go. So let's apply the ratio test, which says if we take the limit as n goes to infinity of the absolute value of the n plus 1 term, so we're going to put n plus 1 in for the n, divided by the nth term, so that's 10 to the n over n factorial. We want to look at this limit, and if this is less than 1, then we have convergence. If it is greater than 1, we have divergence, and if it equals 1, it's inconclusive. So let's check it out. And a lot of times, because you know you're going to be doing this ratio and you always have this second fraction that you invert and multiply, a lot of times you just kind of do that as you're writing it. So let's go ahead and flip it over, and we have here 10 to the n. And of course they're inside the absolute values. And now typically we want to split this up. This is 10 to the n and 10 to the 1 by rules of exponents, and the 10 to the n's will cancel. And then on our factorials, n plus 1 factorial would be n plus 1 times n on down for the factorial, and so the n factorial pieces will cancel. So let's write down what we have left. We have the limit as n goes to infinity of, we still have this 10 on the top, and then that's going to be over n plus 1. Well, as we let n go to infinity, fixed numerator, denominator becoming large, this limit equals 0. So by the ratio test, this series converges. So let's go ahead and apply that one more time. Let's try it on this one. And so we have the limit as n goes to infinity of the n plus 1 term, we need absolute value here, and this would be to the n plus 1 over n plus 1 factorial. Now I'm going to go ahead, and I would have divided by the nth term. I'm going to go ahead and flip it over to multiply. So that'll be n factorial here, and then n to the n there. So now let's see what we could do to simplify that. This is n plus 1 to the n times n plus 1. This n plus 1 factorial is n plus 1 times n on down. So let's see if that helps us at all with anything that we wanted to do. Now I look at that and see that the n factorials will cancel and the n plus 1s will cancel. So let's write down what we've got left. We have the limit as n goes to infinity of n plus 1 to the n over n to the n. Now I'm going to rewrite that. I'm going to, because everything's to the nth power, I'm going to just put the nth power once. So this is as n goes to infinity of, I lost these. Okay, so this will be n plus 1 over n to the nth. Now I'm just going to express this a little bit differently. We have the limit as n goes to infinity of the absolute value. I'm going to put the n under each term, so this would be 1 plus 1 over n to the nth. Now we actually saw this when we were working with limits back in Calc 1, and you may or may not remember that, but that actually converges to e. And if you don't remember that, I've shown you that in this video, and as we work with power series, which is coming up soon, you will definitely see why that's true, even if you don't remember it from Calc 1. Okay, so what does this tell me? The limit equals e. Well, e is greater than 1. E is 2.718 and keeps going. It's greater than 1, and so that tells us that this series diverges.